Assalamualaikum and good day, student. We will continue to our exercise on the relative velocity method. Okay, before you start, you need to have those compass set and protector to complete the drawing of relative velocity method, velocity diagram. Okay, let's say this is given the slider crank with a link OB and BA. So given the, hold on for a while. Okay, given the dimension of OB and AV as stated here, and then the crank is moving clockwise at 180 RPM, at an instance where, let's say, we freeze the drawing at 45 degree over here. So let's see what is the velocity of point B, and then the most important is what is the velocity of slider A over here, and then also the angular velocity of link AB. What is the angular velocity of link AB? Second question is afterwards, based on your velocity diagram, you need to calculate the velocity at point C. Point C is located at the middle of link A and B. Okay, let's see how you solve the problems. Okay, what you need to do first is this is an imagination on how the crank works. You see the direction over here. When we freeze at 45 degree over here, for sure this is the velocity of point B to velocity of point B from O with respect to O. Or this is the fixed point. O is the fixed point. Velocity of point B from A, this is the direction actually, and then this is the velocity of A with respect to O. Actually, there is another velocity over here, which is velocity of point A with respect to B. If you know that the direction of the only difference between VAB and VBA is the direction, the magnitude is the same. Okay, this is your expected velocity diagram afterwards. This is what you are going to draw afterwards. This is the final triangle that you should have afterwards. Okay, first one, calculate the velocity at point B, VBO, when we freeze at 45 degree. You know that this using the rotation of the crank at 180 RPM, and then using the equation of V equal to R omega, and then R is the length of OA, and omega you will get from the equation of 2 pi n over 60. So you will get the answer of velocity of VBO is 9.425. Okay, so this is 9.425. Okay, now imagine the relative velocity direction of VBA and VAO. As you know just now, this is the VBA, and then this is the VAO. Okay, so you need to draw the space diagram according to your relative velocity, according to your identified relative velocity at a certain point, at any point, let's say point A, point B, and point. Okay, let's say this is only 3 points, is it? Okay, this is the one that you need to draw first to make easy afterwards. Okay, how to draw the velocity diagram? We start from VBO. VBO, since you know the magnitude 9.425 meter per second. So what you need to do is you need to, okay, before that, this is your expected velocity diagram, is it? So what you need to do is you need to using any scale, like say 20 mm is equal to 9.425 meter per second. You need to draw vector VBO, this one, you need to draw vector VBO according to the direction. You may start at any point as you wish. You may start here, you may start here, but in this case I start at this point, so I start at point O. Let's say this is point O. So you draw 20 mm length according to the direction. So you need to measure this one, the angle. You need to measure the angle theta over here, and then you draw again over here within the same angle within the 20 mm is equal to 9.425. Okay, so the next one, okay, you bring it over here. The next one, you need to draw the VBA, velocity of V relative to A. This is unknown magnitude, so this is unknown magnitude, but knowing the direction, is it? You know, you still can measure the angle. So you just bring it over here. So we don't know actually. You need to draw all along the way from here within the direction. Okay. Later we'll see what is the importance of crossing this one. Okay, next you need to draw the VAO. You know that VAO is horizontal to the right, so you just bring it, start from O, velocity of A from O. So you draw horizontal to the right from O, crossing this point. So crossing this point is actually point A. Crossing this point is actually point B. Okay, this is point B, this is point A. Okay, this is your complete velocity diagram. You already have your complete velocity diagram. So now you can start answering the question. The question is asking for velocity of A slider from velocity of slider from O. So what you need to do is you need to measure the length of this line of your vector. You need to measure this length and then compensate with the scale that you selected before. Okay, so by measuring this length, so you'll get the answer of velocity of AO, velocity of slider is 7.84 meter per second. Okay, the next question is asking you to get the angular velocity of AB, link AB. So you need to find the angular velocity of link AB. You know that V is equal to R omega. So you erase back the equation. So omega equal to V R, and then what you need to have is the VBA. From measurement VBA, so again you need to measure this length and then you compensate with the scale that you selected before, and then you put into this equation VBA. AB is the length of the link, length of link AB to 2 meters. So from the equation you can get the answer of 3.393 radian per second. Okay, the last question is asking you to get the velocity of point C. Point C. Point C is located at the middle of link AB. From the velocity diagram just now, so you just simply put the point C at the middle of this velocity diagram, and then once you already put the point C at the middle, so you just draw another one line from point O over here to point C. So the length of this vector O to C is representing the velocity of point C. The length you compensate with your scale before, so you will get the velocity of point C relative to O is 8.106 meter per second. So basically that's all. Thank you.